Hello, my name is Ana Cruz. I come from ISEC Lisboa, Instituto Superior de Educação e Ciências in Portugal, and I'm going to present the work Vermicomposting, an idea to work science and mathematics in primary education. This work was performed by three pre-service teachers, Hugo Castanheira, Patrícia, Morgado, and Raquel Pereira, and two college teachers, myself and Ricardo, Machado. What we have noticed in Portugal in the last years is that educators and teachers always show very little flexibility in their classes, following strictly by the book. And also they have to cope with extensive curricula and external evaluation institutions. This, together with a lack of experience, is possibly the main reason why they don't like to work and they don't use to work science and mathematics in their classes. So we wanted to present our students with a different strategy. So we chose IBL, and also we wanted to show them that it's possible to work mathematics and science in an interdisciplinary way. So we will use our both classes, methodology for teaching mathematics and experimental science practices, to present them and to work with them the IBL strategy. And also for them, we ask them to design and implement a proposal that they would use as future teachers, future primary education teachers. So we all know that inquiry-based learning is a strategy that has multiple advantages, such as the promotion in students of curiosity, observation, and participation. It makes them work in a way that a scientist would do, so it introduces them to scientific methods, developing critical thinking, decision-making, autonomy, conception of hypotheses, etc. So for them, as future educators and teachers, this is a valuable approach. The possibility of planning activities that promote interdisciplinarity, the possibility of collaborative work and working different types of knowledge are according to Portuguese curricular competencies for the 21st century skills. So, as a method, we use an interpretive paradigm, doing an accent research project. The participants were our five, as I've told you, and we use documents investigation, experimentation, observation, students' protocol, and informal conversations to collect data. In fact, our main goal was, and above all, to develop an IBL strategy from a contemporary science issue that could be proposed by students, in which they integrated both mathematical knowledge all along, and science, of course, all along the investigation. So the first thing was to choose the problem. And this was done by students with our guidance, of course, and they chose, this group in particular, chose what to do with food home leftovers. So they started by an initial investigation, which was performed by them, and ended by choosing from all the possible solutions, vermicomposting, because it was eco-friendly and easy to implement and very cost-effective solution. After they designed a proposal task that they could implement in the classroom, following the IBL strategy, and it was followed by the development itself of the proposal. They chose the third graders as the target for the implementation, the proposal implementation, and they worked both mathematics and science, as it was asked, to collect, interpret, and conclude about all the data obtained. Interesting, they ended by choosing a second investigation. There was the practical use, the implementation of the compass that they obtained previously. During all the procedure, we never forgot the technical accuracy and the scientific rigor as far as language and procedures are concerned, of course, adapt to the third grade. So the project was developed in several phases, which are, of course, integrated in the RBL phases. From the starting point, the food waste and what can we do to the food waste, the initial investigation. In science, they calculated the amount of food waste produced by each of the students of the class they chose. This was a simulation, of course, but everything was calculated accordingly. They calculated the amount of food waste produced by all the class and by each student individually. In the conceptualization phase, they discussed about all the technical and practical characteristics of what to do. So what would they choose to build the vermicomposter? What are the conditions that control the composting? What are the benefits, the future benefits for the soil? What are the conditions that worms they chose needed for living, surviving, and of course do the composting? In terms of mathematics, they work counting and checking the size and weight of the worms all along the process. They measure the dimensions of the composter itself, analyze the characteristics of the composter and the volume of the soil, they have to introduce. And of course, the waste, the type and weight of the waste that it was put every day in the composter, sorry. The following phase of investigation, they used all the investigation using books, etc. They build the vermicomposter itself, record all the evolution that of everything that happened during all the following days. They constructed a diary, a research diary, and they checked the evolution of the study variables: pH, temperature, humidity, type of waste, etc. In the mathematics, they recorded variable data in the research diary every day. They checked the results also weekly and monthly. This project, I didn't say, but this project took the whole semester to be performed. It was performed all along the semester. They check every result they check, they constructed graphs and tables to register, and then they discuss the results. To conclude, they verify that some foods can lead to mosquitoes and shouldn't be done when it was implemented in a class, for instance, so they had to avoid this food. That there was some food the worm showed some preference, that they decompose almost what they weighed, which was interesting, and that there were residues that they should use and residues that should not use because of the different decomposition times. Also, the different physical conditions were somehow determinants of how the decomposition was performed, because it interfered with the worm activity. Also, they realized that the survival of worms was thermoregulated. We had different temperatures during all the semester, with temperatures that range from 15 to 30 degrees. And so they were able to follow all the activity during all this time. The production of humus, or the compost, as you can call it, was then used to the second investigation, which was what to do with this. And what to do with this is to use it for instance, to grow plants. We use lettuce, but you can use everything that has a time of growth rapid, so that children won't get bored. So this is an example of the research diary. It's in Portuguese, but to resume, it has the type of worms that were chosen and why, all the characteristics. And this is the example of a daily register in which they put what type and weight of residue, the aspect, if it smells or if it doesn't smell, if the environment was dry, humid, what was the temperature, what was the pH, and what, how much earth did they add? How much water did they add was also a very important variable, and notes that I thought it was important. This is the register, a weekly register, in which you can see they simulated how the children could do this register. So it's the total amount of residues from day 1 to day 7. So in day 1, they had a lot of residues, and in day 7, effectively, then there was less residues. These are photos. This is a photographic diary. Also, this is almost a month of what happens both to the worms and to the residues. So as you can see here, they use all kinds of residues, from paper to banana to carrot and etc. This is the initial amount of worms they started with. And so after this humus, the first investigation arose, the one that I told you about with the lettuces, in which for the science, they verified if this humus was or not important for the growth, if it interfered with the growth, and of course the mathematics compared and discussed the results. And I concluded that the soil enriched with composting alters positively lettuce growth. So to do this, they used a soil with compost and a soil without compost. You can see the two lettuces here. And they realized, in fact, that they measured the size, the length of the leaves of the lettuces, and they verified that the ones with compost in the soil were more healthy, and they grow a lot faster than the ones that didn't. This is also an example of the diary, the research diary, also with the register. This is a daily register with the photos and the description of what they observed. Here you can see a photographic diary. So to conclude, and as a final remarks, we thought this was very well succeeded. They understand very well how to use the IBL strategy and how to combine science and mathematics to do so. So it was, in fact, an interdisciplinary proposal. It was their proposal, just guided them, and they developed a lot of competencies that we were expecting. But I think the most important thing is that they realized how differently the sciences and the mathematics can be worked in a class, and they developed collaboration between these two classes. It is also important to notice that this was only possible because the teachers, me and Ricardo Machado, had the opportunity to collaborate, which is not always the case in schools, and difficult a lot this kind of work. But it was very well succeeded, and for them, as they said, it was very thought-provoking, not only because it was a different theme, but also because they realized how important and how necessary it was to work both curricular units all together. So we think It was very nice and very interesting to work. So thank you for your attention. Bye.